Right. So, can we say that some of these chemicals or these chemicals that we are talking about can be said to be matter? Hello? Are chemicals matter? Hello? Hello?
Yes, sir.
Yeah.
Yes, they are. Yes, bro.
Yeah.
Right.
Yes, sir.
They are matter
Well, bro.
because they have weight, right?
Please, when you are in class and you are in noisy place, the
Please,
Mute
can
best thing
you
yourself.
to do
mute
is to
yourself?
mute
Mute
your
yourself.
mic.
Mute yourself, please. Please, this is the first class, so please don't give us impression. What's it? You want to say something? What's it, James?
What's his name? You can unmute yourself, yes.
No, I said the chemicals are matter.
Chemicals are matter because they have some weight, high, some space. Is it also?
Yes, sir.
Right. So, matter, we are told, is the material substance that constitutes the observable universe, and together with energy, they form the basis of what? Objective phenomena.
Phenomenon.
Yeah. So that is another definition of matter. It's a material substance. It's a substance, okay, that constitutes the observable universe, together with energy, forms the basis of objective what? Phenomena, right? So we have 4 fundamental natural states of matter. We know that matter can also exist as a liquid, right? It can also exist as a gas, solid, liquid, and gas. Gas, we have air or oxygen. Liquid, we have water. Solid, we have, you could refer to solid, maybe ice block is a solid. The chairs we have are solids. The table is a solid, and so on and so forth. And then you have the fourth one, which is referred to as plasma. You have plasma, which is the fourth, state of matter. And the question is, what is plasma? What is plasma in chemistry? Any idea? Because I'm sure you know of solid, you know of liquid, you know of gas. Is it not so? But plasma has also come in at this point. So what can you say is plasma? Any idea? Hello? Hello, guys.
If you have an idea, raise up your hand or write it in the chat box.
Any idea of what plasma is? You don't know. I will let you know what
no,
plasma is.
someone say it's a media.
It's a media.
Yes, plasma is a fourth.
Someone has
when
written up. I've seen it.
yes, sir.
Is the fourth state of matter. That's correct. It consists of very high energy. Okay.
Ionization.
Ionized gas.
Yes.
Containing free electrons and positive ions, making it electrically conductive and responsive to an electromagnetic field. So plasma is the fourth state of matter. Someone has written after solid, liquid, and gas. So it consists of high energy, consists of ionized gas that contains free electrons and positive ions that make it electrically what? Conductive. So it means it has a lot of energy based on that. So the temperature is also very high, contains very high temperature, so on and so forth. So you're correct, composed of free electrons and positive ions. So that is what plasma is generally. Yeah, you're correct. I'm reading what you're saying. That's all right. That's all right. That's okay. So matter, as you know,
Hmm? I guess network is playing the devil on us again. Prof has been thrown out again. Okay, Prof is back. Prof, you are back, sir.
it's fluctuating. And I'm moving from one point to the other. That's a challenge that we usually have, with this online teaching. You may be very unlucky. I'll be having challenges with this. So I am saying that in general, a chemical substance is matter, just like we rightly said. So matter we said is of constant composition. It contains molecule, chemical substance, or just what? A chemical. And chemical substances are characterized in a number of ways. In other words, they have different kinds of properties. Mind you, the topic effects of to be able to have effect on the environment, they need to have certain properties that we, make them act in that manner. So that is what we are talking about here. So they have properties, they have characteristics, okay, that you can, use and in a way be able to explain their effect or explain how they affect the environment. So chemical substances, like I mentioned earlier, are characterized properties include density. So a material may affect the environment if it has a particular density, and so on and so forth. Okay? Refractive index is also another physical property of this. If you have a material that conducts electricity and you have a material that does not conduct electricity, that will give an idea on how that material is going to affect the environment. Another one is melting point. Okay, melting point. You have a substance that melts at higher temperature. You have another one that melts maybe at lower temperature. That would also give you an idea on how that material could affect the environment based on their what? Melting point. Then you have chemical properties, which include the oxidation state. When I say oxidation state, see, there are some substances that have more than one oxidation state. Those of you who are chemistry inclined, when I say oxidation state, I'm sure you know what that means. The outermost electrons that an element do have, okay? So to speak, they are positive or they could be negative. Positive when they lose electrons, negative when they gain electrons. So you have, for instance, zinc 2 plus, okay, Fe3 plus, okay, Cl minus, something like that, right? That is what we are referring to as oxidation state. And then the acidity, okay, acidity. If a material is acidic, you know what that means. If a material is possessing acidic nature or has acidic nature, you know what that means. If a material is flammable, you know what that means. If a material is radioactive, you know that means spontaneous disintegration. And that will also tell how much that material will affect the environment, toxicity, and a host of them. So chemicals can either occur naturally or can be created. You can create chemicals. You can also, they also occur naturally, and you can also create them or synthesize them. We're talking about creation here is synthesis. You can synthesize them in the lab. The natural compounds or the natural chemicals that you see around us, there are some of them that you can, synthesize or produce them in the lab. That is what we mean by can be created. Okay. A number of these elements, like I have shown, or as it is being shown in the screen. You have the iron, you have zinc, you have helium, oxygen, compounds, oxygen compounds, elements. You have iron, zinc, helium, oxygen, right? Compounds you have water and more complex materials like soil. You can generate oxygen in the lab in natural form. Can be synthetic. Hello?
Yeah, Prof, sorry.
Hello, are you with
Maybe,
me?
yes, sir. Help us
Yes, please.
take the slide, take the slides to slideshow again. It's a bit far from us. Yes. Thank you, sir.
Hello?
Prof, it's as if network took you out again, but you are back now.
Yes, the network became bad. I'm back. I'm trying to share the screen now again. Right. Slideshow. Right. Are you there?
We are, sir. We are, sir.
All right. Right. Thank you. Yeah. So I was saying that chemicals can either occur naturally or can be created. Okay. You can synthesize them. In as much as they occur naturally, it is possible that you can create them. You can synthesize them in the laboratory. And I was trying to give you some examples of these chemicals or elements. We mentioned iron, we mentioned zinc, we mentioned helium, we mentioned oxygen as elements. And then as compounds, we have water, compound because they contain more than two atoms. H2O, carbon dioxide, table salt, which is sodium chloride, and other complex materials like soil, air, rain, food, concrete. All these are also. So the next picture you are seeing here is an attempt to classify matter, is an attempt to classify chemicals, because we have agreed that chemicals are matter. Matter are chemicals, and so we want to see how we can classify them. So they can occur as pure substances, or they can occur as what? Mixtures. So as pure substances, you could have elements, compounds. Okay, you can have a mixture that is heterogeneous, that is a material or a chemical or a substance that is made up of, different phases. You have homogeneous. Homogeneous has to do with the same material, made of the same material. Heterogeneous, made of different or mixed materials. And under heterogeneous substances, you have suspensions. Okay, you have emulsions. I'm sure you know what a suspension is. Maybe you have dust particle being suspended in air. That is suspension. Then you have emulsions, where you have maybe oil mixed with water. You have solid, so also have aerosols, and so on and so forth. And then other homogeneous material or substances or chemicals, you have gas mixtures. You have gas mixtures. You have solutions. You have alloys. So this is an attempt to classify matter. So matter can either be classified as a pure substance or as a mixture or mixtures. And then if you go under each of the headings, then you begin to have examples of pure substances or how they exist as a pure substance, and so on and so forth, or heterogeneous substance or homogeneous substance, and so on. So the examples are given, under each of the heading. Any question, any clarification that you need at this point? And if there's anything that we have mentioned here that is strange, that you don't understand, this is the time for you to raise such a concern. Hello? Hello? Are you there with me?
Yes, Prof, we're with you.
Right. So any question, any clarification, so to speak? Right.
There's a hand up here, Dugeri.
Okay, Dugeri.
Dugeri,
Yeah.
you can unmute yourself and speak.
Yeah, please, can you go ahead and speak, please?
Prof, good morning, sir.
Good morning.
Good morning, my students. I want to ask about the types of matter or the classifications of matter. In our secondary school days, we were taught that matter has three classifications, which
Yes.
were solid, liquid, and gas. But here you added plasma.
Yes. Because plasma seems to be a distinct, how do I put it? It's a bit different from liquid, from solid.
So my concern is on that plasma, neat component of matter. Thank you, sir.
Yes,
Prof, am I heard?
that is what
Prof,
I'm saying.
am I heard?
I am saying, yes, we're asking that there is a fourth state of matter, which is plasma, right? And I am saying that if you look at plasma based on its composition and definition, or even nature, it is a bit distinct, or is a bit distinct from the three that you have mentioned. Mind you, they say, like here, you see, it is not a common state of matter here on Earth, but it may be the most common state of matter in the universe. All right? So it is part of matter. It is a state of matter. If you are not told in the secondary school or primary school, it is not everything that you need to know at that level. As you move forward, the understanding at that level is different from the understanding now. So it is believed that at this point, your understanding will be better than when you were in secondary school. Okay? Hello? Hello?
Yeah, you, sir.
Mind you,
Fire on that.
they say that plasma is the fourth state of matter. It's consisting of high energy ionized gas containing free electrons and positive ions, making it electrically conductive and responsive to electromagnetic field. It forms when gas absorbs enough energy, all right, for atoms to ionize, typically at high temperature. So this description should tell you that it is a bit different from the usual three that you know. Okay? Hello? Is the
Prof, we are with you, sir. Yes, sir, we are with you, sir. I can hear you loud and clear.
Yeah, so the nature of this one is completely different from the three that we know. Okay? And that has brought us to the various physical states and the change of states of matter. Okay? Now we have solids. We have mentioned solid. And matter is made up of solid, liquid, gases, and plasma. And here, the description will distinct each of them, okay, from one another or from each other. Like in the solid state, the particles are packed, very tightly so that they do not move much. Okay? They do not move much. And you can see that when these particles are tightly packed, it becomes difficult for them to even conduct electricity and so on and so forth. What they do at this level is to vibrate, and they are found in a fixed position, all right? And they have a definite shape and volume. So if you look at liquids particles are more loosely packed than in solids and are able to flow over each other. They conform to the shape of the container in which they find themselves, and they are difficult to compress. Very, very difficult to compress. So these characteristics are what has differentiated each of these states completely. Then the gas particles, they have light space between them and high kinetic energy. Okay? And we are told that they have no definite shapes or volume, and they are highly compressed because of the spaces, that you find in between them. They can be compressed so easily, right? And then the plasma itself, which we have described. So look at the characteristics of solids, liquids, and gases, and then compare them with the plasma. Then you can see that that is another, state of matter entirely. So today you are knowing that matter is not just made up of solids, liquids, gases, but it's also made up of what? Plasma, which are produced at very high temperature. And they have both electrons, they have free electrons, and they have positive ions too. that, help them to conduct, electricity very, very easily. Okay? Does that make any sense? Hello?
It does, sir.
Right. So this is just a picture of change of state of matter, because there are some of these materials or chemicals that can change state. They can change their state, at given conditions. They can change state. You have solid. The solid can melt. You see, solid is melting at high temperature or at elevated temperature. You will discover that the solid will do what? Will melt into a liquid. The liquid can freeze to return to where? To return to the solid state. And the gas can condense to become a liquid. The liquid can evaporate to become a gas. And there is a possibility that the solid may not pass through the liquid state and then move straight to the gaseous state. If you look at the topmost arrow, can you see that? Hello?
Yes, we are following, sir.
Right, the topmost
Loud
arrow.
and clear.
The topmost arrow, you see, it is moving from the solid state to where? To the gaseous state. So what kind of activity is taking place there? What is that process called? Hello?
There are comments in the chat box, sir.
Okay. Sublimation, right? That's true. Sublimation. What is sublimation? Sublimation is the process in which a solid changes directly to where? Or straight to where? To a gas. It's the process in which a solid material changes its form to where? To the gaseous what? Form. And what example? Can you mention one example of a chemical that changes its state from solid straight to the gaseous state? Can any of you mention one example? Solid state to gaseous state, that is sublimation. All right? That's all right? Camphor, that's right. How about iodine? Iodine is another example, okay? Iodine is another example. Right. Thank you very much. Now, we have resources in the earth, and these resources are air, water, land, plants, animals, humans. Is that understood? Somebody is putting up his hand. Ayobo, can you speak?
Yes, sir.
Yes.
Yes, sir. Good morning. Oh, good morning, my colleague. From the previous figure you gave us, this figure two, changing of gases, solids to gases, solids to liquid, and so on and so forth. You made mention of a state of matter, plasma. Can this figure demonstrate how solids can change to liquid, to gases, and to that plasma and all of that? I don't know whether you understand what I'm trying to ask.
No.
Like
How solid can
change to liquid, to gas, or to plasma, or solid can change directly to plasma, or liquid can change to gas to plasma, something like that.
Hello?
Yes, sir. We are with you, sir.
You said I should explain how plasma does what? Okay, all right. Okay, how you can move from maybe solid to plasma, or liquid to plasma, or gas to plasma, something like that. Hello? Hi, man.
Yes, sir. Yes, sir. Where with you, sir?
Now, okay. For instance, a gas can change its state. That is from a gaseous state. A material can change its state from the gaseous state to plasma. For instance, when you subject that gas, are you hearing me? When you subject that gas to an extreme high temperature, are you hearing me? Extreme high temperature. If you are able to heat a gaseous material to a very high temperature, the resultant change that you are going to see or observe will be a plasma. Mind you, we are told that a plasma contains ionized gases, is it not so? The gas will become ionized, all right? And it will also release free electrons because you have subjected it to a very high temperature, okay? Or stimulation. It could be electrically. It could be electrical stimulation, kind of. So when you subject a gas to a very high temperature or heat, the gas could become ionized. And at that point, you are approaching, or you are getting to that state that is called plasma. Did you hear me?
Yes, we heard you loud and clear, sir.
Yeah, so when you subject a gas to a very high temperature, and the gas ionizes, then you are likely to approach a plasma state. Okay, I think that is the only definition I can give. And it is possible that when that gas cools down, if it cools down, it can return to the gaseous state after cooling. Okay? Did you hear me?
Well, we are with you, sir.
Right. So some of these things sometimes, as it is mentioned here, you can also read more about it at your private time. So I was trying to say that we have resources in the earth, or we have resources in the environment, and these resources include air, water, land, plants, animals, and humans. So the idea here is to let you know that the air is also made up of chemicals, okay, as the building blocks. The water is also made up of what? Chemicals. The land is also made up of chemicals. The soil is also made up of what? Chemicals. All right? In the soil, you can find air. In the soil, you can find organic matter. In the soil, you can find oxygen. In the soil, you can find nitrogen, all right? And so on and so forth. In plants, you can find some of these chemicals. In animals, you can find it. Even in humans, you can find these chemicals. So these chemicals, they form the basis of life. That is what this heading is talking about. The chemical essence of life on earth, all right? It's simply telling you that whatever that you have here on earth, the building block of it is the chemicals. So you can see that chemicals are found everywhere, including, in humans, animals, plants, and so on and so forth. So the composition, what matter is composed of, the structure, the properties, and the kind of reactions, okay, of these chemicals or building blocks, so to speak, they underpin the essence of life and other natural phenomena, right? There are certain reactions, there are certain actions, there are certain reactions that take place in our system that make us, all right, to remain alive, that make us to do certain activity. In the absence of such reactions, like biochemical reactions in our systems, life may not continue. So these chemicals, okay, they possess certain properties, they possess certain structures, they are composed of certain materials that make life, very, very meaningful, so to speak. Now, we have another figure in the next slide. That is figure 3. It is trying to show us some of these chemicals that we have on Earth or in abundance, and as the Earth and the Earth crust, and so on and so forth, right? So that picture or this figure that you're seeing here is telling us about the most abundant, that is composition wise, most abundant elements of the earth and the earth crust. Now the question is, what is earth crust? Or what is the difference between the earth and the earth crust? Can any of you tell us the difference between the earth and the earth crust? Hello?
Yes, sir. They were putting it in the chat box.
Right. The difference between the earth and the earth crust. Yeah, somebody is still talking about changes of state. We have passed that level. Which of the pie chart is for earth and which is for the earth crust.
So there are some answers in the chat box already.
Right. Which of the pie chart is stated that gas temperature can change the plasma state to reverse when cooling? Yeah. Then the process is called, right? Air crust is the outermost solid for this layer. Cross mantle is okay. Is our house. Okay.
So we are hearing voices from your background, sir. I think from the
Yes. Got it. Close that door. Close that door. Yes, the noise is too much. Right. There is no distinction between the earth and the earth crust here. It's just showing you a general composition. There's no specific one for the earth crust or specific one for the earth. This is just trying to show you, the different composition of these chemicals or elements in the earth and the earth crust. There is no distinction here, so to speak. Let me see. Hey, my battery is getting, there's no light here yet. My God. We have to switch to my phone. Sorry, permit me to switch from my laptop because there is no power supply in the university yet, and my laptop battery is running down. So permit me to switch to my phone. Okay?
Okay, sir.
Yes.
You may not need to log out. You just use the link and join from your phone.
Yes.
So that by the time your laptop disconnects, you can just continue from the phone, sir. Hello, we are waiting for Prof. Prof took permission to change his device, and we are waiting for him to make that change and return to class. So there is no sound anywhere. He took that permission, and we granted him to change his device. His laptop ran down, and he asked that he should change his device and come back. I think Prof is back in class. Prof is back now. Prof, you can unmute yourself and continue, sir. You can unmute yourself, Prof. Please, Prof, you can unmute yourself. Okay, good morning once again. Prof is here with us, but I don't know the difficulty he's having. He has not been able to unmute himself, and so we can continue with the lecture. Let me try to call him on a normal call. I've tried calling him on WhatsApp, but not successful. Let me call him on a normal call and see. Prof will soon be with us.
Okay. Hello. Kai. Hey. Hello. Hello.
Prof, we are with you, sir.
Yes. Can you hear me now?
Loud and clear, sir.
Okay. Okay. Good. The challenge now is I can't see the. Okay. 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 Right. All right. So we're trying to emphasize the importance of these chemicals to life on Earth. I think that is the main thing that we were trying to talk about here. So we said that somebody asked a question about the Earth crust and the Earth. If I could, can you go back to the Earth and the Earth crust? Yes. No, not this one. The picture, the figures. I think this is what. Okay. So the one on the right is the Earth crust. Are you hearing me?
Yes, sir. We can hear you, sir. Loud and clear.
Yes. The one on the right is the Earth crust. That's the composition of those elements in the Earth crust. the figure on the right. That is on my right. But that should be, yes, on the right, yes. And the one on the left is the Earth. Can you get me clearly now?
Yes, we can.
Yeah, so the one with 46.6% of oxygen is the Earth crust. And the one with 29.5% oxygen is the Earth. If you look at other figures, this 29.5 is approximated to 30. If you look at other figures, it is 30 that is there. There is no much difference. It's just an approximation. Okay? Hello? I think I've answered that question now. Can we go back to the essence of the chemicals on the earth? The chemical essence of life on the earth. We're talking about resources. It's the one that mentioned resources. I think it should be. All right, we are. Oh, no, not that one. Backward. Yeah, no, not this. Yeah. So, no, not here. Move forward. Yes, this is what I'm talking about here. Yeah. So what we are, okay, move to the next slide. I think we are done here. Right. So I've told you what now the chemical essence of life on Earth continues. So we have said it already, and we are told that the Mother Earth is the only planet that supports life in the universe, and life exists due to the balance in the natural geochemical cycles. If there is no balance, there's no way life can exist on this earth. Okay? So there must be a balance of these chemical substances in the earth for us to be able to do what? Survive, and so on and so forth. Okay? That is what that thing is saying. So we are told that the natural geochemical cycles, that is NGC, natural geochemical cycles, are important to life are the water, carbon, nitrogen, oxygen, phosphorus, and sulfur cycles. And these are powered by the sun. So this is just telling you the essence of these chemicals to life, the importance of these chemicals to life. Without these chemicals, there is no way we can survive. But that is when they are in the right proportion, when they are in the right amount. But the moment these chemicals are above maybe the limit that is required for them, okay, to make meaning to us, they become poisons. They become, they begin to pose a kind of a threat to the environment and even to humans. So the air we breathe is a mixture of gases. All right, it's a mixture of gases. Nitrogen, oxygen, water vapor, noble gases, and carbon dioxide. The water we drink is also very important to life, and it's a solution of dissolved minerals. Okay? So just imagine life without water. Water is a chemical. Because we are told that made up of different so you can see that you can see that life is generally made of chemicals. Okay, there is nothing on earth that is not made of chemicals. But like I said, if these chemicals can only make meaning to us if they are in the right proportion. The moment they exceed the concentration that are needed or that are required, or the minimum permissible limit, then they become poison. They could affect human health and even the environment. We are also made up of natural chemicals. We are very familiar of DNA. DNA is a chemical. Hemoglobin is a chemical in blood. Urea, you find it in urine. Calcium carbonate is found in bones, and so on and so forth. So you can see that these chemicals are of essence to life on earth, and without them, there's no way we can, survive. Next slide. Hello, Ongu. Next slide. Network.
Network has thrown Prof out again. We have to wait for him to get back. Just hope that by tomorrow
maybe by reason of change of position and all of that, we will get better reception for our class.
Hello, good morning, people. The network has kicked Prof out, and I don't think the class is going to hold again. So let's just wait for the afternoon session. Sorry for keeping you all waiting.
See you guys in the afternoon.
Yeah, bye.